Hello, hi everyone. My name is Nehel and welcome to this OneClass stream. Today we'll be going over a few popular math questions. These math questions are typically from high school to university slash college level. Just a little bit about myself very quickly. So I'm a University of Waterloo graduate. I graduated. I went there to study mechanical engineering, and after completing my graduation, I've been working in the plastics industry for about 2 years. Now my next step is to do my master's degree from University of Toronto, and I'll be starting that in January. So looking forward to that. All right, without further ado, let's get into it. We'll be solving math questions as I said. So let's look through the questions. Okay, perfect. So question one for today is based on circles in geometry. How do you find the diameter from the circumference of a circle? Okay. So we're given a circle and we need to find the diameter. So let's just quickly draw a circle here. Okay, so essentially a circle with we need to find this dimension d, which is the diameter. If we recall the formula for the circumference of a circle, so circumference is equals to 2 pi r. So in our case, circumference, which is c, is already given. So all we need to do is find an expression where we can express d, which is the diameter, in terms of the circumference. If we look at the image more carefully, we know that the radius is nothing but half of the diameter. So from that we can say r is equals to d over 2. Therefore, given that, we can substitute this expression into the formula of the circumference. We can say circumference is actually equal to 2 pi d over 2. The 2's cancel out and we get circumference is equals to pi d. Now we can rearrange and solve for the diameter. So we can say therefore d is equals to pi over circumference, and it will be in the units of length, so we can just say unit length because we don't know in this question what the unit is. So this would be the final formula for final answer for this question. So the key takeaways from this question would be to recall the formula of circumference of a circle and to know that the radius is expressed as half of the diameter of a circle. So yeah, that's the final formula. Let's make sure that it's correct. So diameter is equal to circumference over pi is the final answer. Oops, yes. I did, when I rearranged this, I did swap them by mistake. So this is actually c over pi. Okay, perfect. So good catch here. The solution is correct. Okay, alright, let's get into the second question for today. How do you find the centroid of a triangle? So first of all, what is a centroid? So the centroid of a triangle would be a point located inside the triangle which is equidistant to all of the three edges of the triangle. So we have a triangle A, B, and C. There will be a point O located somewhere inside the triangle such that all the three connecting lines are of the same length. So if this is the point O, the O is a centroid only when AO is equals to BO is equals to CO in terms of length. So now the formula which we use in order to find the centroid is similar to the formula for the mean of a given sets. So if A has coordinate x1, y1, B has coordinates x2, y2, and C has coordinates x3, y3, we would say the coordinate for the mean or for the centroid, the x coordinate would be x1 plus x2 plus x3 whole divided by 3. Similarly, the y coordinate would be y is equals to y1 plus y2 plus y3 whole divided by 3. So if we were to use this equation which we just learned and do a quick question, so I'm going to draw another triangle here. Okay, and it's on this axis, just so you can visualize what it looks like drawn on an axis. This is the x-axis and this is the y-axis. So the first edge is on the origin, so at 0, 0. Let's say this point is at 2, 2, and then this point is at 4, 0. So based on this, if we were to calculate the centroid or x coordinate of the centroid would be equal to x1, which is 0, plus x2, which is 2, plus 4 divided by 3. So that gives us 6 divided by 3, which is 2. And then y coordinate would be equal to 0 plus 2 plus 0 divided by 3, which is equals to 2 over 3, or it's equal to 0.66. So on this coordinate axis, we would have the point somewhere here, so it's a little bit below 1 on the y-axis and exactly at 2 on the x-axis. So this point 2, 0.66 is the centroid, and it's equidistant to all the 3 edges of the triangle. Alright, so let's quickly ensure that's what the solution is saying as well. That's correct. And then they give an example, so 4 plus 20 plus 30 divided by 3, and similarly for y coordinate, so it's at 18, 2, so somewhere here. So that sounds correct as well. Okay, so this answer is correct. Let's get into the next question, question 3 for today. How do you express log 12 in terms of log 2 and log 3? So this is a question based on logarithms. So in order to do this question, we need to know key property of logarithms, which is the product rule for logarithms. So the product rule states that if you have a log of two numbers, x and y, you can actually write this as the sum of their individual logarithms. So log x times y becomes nothing but log of x plus log of y. So given this, keeping this in mind, if we look at log 12, we can look at log 12 as a combination of a few numbers. So we can say log 12 can be written as log 4 times 3, or just to drive my point through, we can say log 12 is nothing but log 6 times 2. So if we were to further solve it using log 4 times 3 and we use this identity here, what would we have? We would have log of 4 plus log of 3. Now, since the question asks us to write it in terms of log 2 and log 3, we can look at this number 4 and say it's actually a product of 2 and 2. So this would become log of 2 times log of 2 plus log of 3. And then again we would apply the rule which we wrote above, and we can say this is equal to log of 2 plus log of 2 plus log of 3, which gives us 2 log of 2 plus log of 3. Now the second way which we are going to solve it, or we can say log 12 is equal to log of 6 times 2, which would give us log of 6 plus log of 2. Now again, since we need to get it in terms of log 3 and log 2, we can say log of 6 is nothing but log of 3 times 2. And then as you can see, we are coming back to our original. So this would split into log 3 plus log 2. And then we would get the final answer as 2 log 2 plus log 3. Okay, let's verify if that's what they've done as well. So log 12 is 4 times 3, which is equal to 2 times 2 times 3 as well. That's perfect. All right. Question number 4. How do you convert 45 degrees to radians? So this is the conversion question. For this, we would need to know the ratio between 1 degree and 1 radian. So the easiest way, in my opinion, to remember that is to know that a circle, a complete circle, in order to draw that, you need to go 360 degrees. So this complete rotation is equal to 360 degrees, which is also equal to going about a circle is equal to 2 pi rotations. So basically from that we can say 360 degrees is equal to 2 pi radians, or 1 degree is equal to 2 pi over 360 radians. So for this question, since we are asked to find what's 45 degrees, we can multiply both sides by 45 in this equation and get the answer. So what we could get is 45 degrees is nothing but 2 pi over 360 times 45. This and this get cancelled. 45 times 8 is 360, and we would be left with 2 pi over 8, or pi over 4, which is equal to 45 degrees. So that's the final answer. 45 degrees is equal to pi over 4, and if we wanted to draw what that would look like, so that would be a point somewhere here, and this would be equal to 45 degrees. So the key takeaways from this question is to just recall that a circle is 360 degrees or 2 pi radians, and then you can use that to convert into any ratio which you're given. Let's make sure that this is correct. 360 degrees equals to 2 pi radians, perfect. And then 45 degrees becomes pi over 4 radians. Okay, let's get into our question number 5 for today. How do I find the base of a triangle if given an area of 48 square inches and a height of 16 inches? Alright, this is again another geometry based question. In this question, we're given the area and the height, and we need to find the base of a triangle. So the key concept which we need to know for this question is the formula for the area of a triangle. So if you recall, if we're given a triangle ABC, which has a base of B and a height of H, we can say that the area of this triangle is nothing but half into base into height. So in this given question, we're actually given two of these quantities and we need to find the third quantity, so we can easily do that by rearranging for that. So in this question, we're given the area. So 48 square inches is equal to half times, we don't know the base, so we will leave that as b, half times b times 16 inches. So to get the answer, we can rearrange for b, which is the base in this question. So this would go to the numerator, and then the 16 would come down to the denominator. So we would be left with 48 times 2 divided by 16. 16 times 3 is 48. So we will be left with 3 times 2 or 6. It's important to note that 6 is the correct answer numerically, but we need to identify the units as well. So since we were given the area in square inches and the height in inches, when we divide square inches by inches, we will be left with inches. So the answer is 6 inches. It's very important to specify the units, otherwise we might get our marks deducted or the answer might be considered incomplete. Another way of writing inches is actually, you can just say is equal to 6 and then write this 2 marks on top. Okay, so looking at the solution, area is half into base into height, base is 2a times h, divided by h, so this is correct. Okay. Question number 6. What is lattice method of multiplication? So this is going to be a little bit of drawing required from my side, so please stick with me. So lattice method of multiplication can be also named as crisscross method of multiplication. So basically it's a more visual way of multiplying two numbers than the long multiplication formula. So let's look at an example where we multiply two numbers. Let's take a 3-digit number and a 2-digit number. So let's say for question number 6, we'll be multiplying 123 and 45. So the way we would approach a lattice multiplication question is, first we would need to draw a table and write out the different numbers we have and split the table into rows and columns based on the digits or the ones and tens and hundreds places in a number. So for this question, we would write down 1 here, 2, 3, and then 4 and 5. And then we would split this rectangle down into equal proportions for each of the number. So we would have one line going through the center, so this, and then one vertically, and then another one dividing 2 and 3. Okay, so now that we have divided these, we need to draw diagonals. So as I said, lattice multiplication is also known as diagonal multiplication. So it's more visual and it's easier to compute than longer multiplication in some cases. So the way we would draw diagonals is that we would look at a point here and then go to the diagonal of this rectangle. So this would be considered one diagonal. This, we would go to this point here and then keep going to the next point, next diagonal. Similarly for this point, we would go to this diagonal and then keep going to the next diagonal. And then for this point here, we would keep going to this diagonal. Alright, so now that we have drawn all the diagonals, the next step is to multiply the number here with the number corresponding to the row, and then write that down in these two diagonals. So in the lower diagonal, we would have the number in the ones place, and then in the upper diagonal we would have the number in the tens place. So for example, 1 times 4 is 4, so there is nothing in the tens place, and then on the ones place there is a 4. Similarly, 2 times 4 is 8, so there's nothing on the ones place, on the tens place, and then 8 on the ones place. In this case, we have something on the tens place as well, which is 1. Since 3 times 4 is 12, so there's 1 here, and then 2 here. Now we do that the same thing, but for 5, which is the second row. So 1 times 5 is 5, so 0 and 5. 2 times 5 is 10, so 1 and 0. Then 3 times 5 is 15, so 1 and 5. Now that we have computed all the diagonals in this rectangle, what we would do is we would add all of these shaded regions. So you would look across each diagonal and add them. So for example, let me just change my color here. So for example, I would add this shaded region and write that down here. So that would give me 5. For the next diagonal, we just quickly change the color so it's easier to follow. So I would look at this diagonal here, and I would add all of those down. So 2 plus 1, 3, 3 plus 0 is 0. Similarly, for the next one, we would add all of these down. If there is a carry forward, it goes up to the next diagonal. So in this case, we have a carry forward since 8 plus 1 is 9, 9 plus 1 is 10, 10 plus 1 is 15. So we have a carry forward. So that would go on the left hand side or the left hand diagonal. So if we were to add all of this up, we would get 15. We would get 1 here. We add this diagonal up, we would get 5 again, and then 0, since this diagonal is 0. So basically, the answer, if you were to read, is if you would look at these numbers as your final answer, the numbers which you've calculated on the left hand side. So your final answer in this case would be 5,535, which is the multiplication. So now this method might seem tedious at first, but as you get more practice in, it'll just keep getting easier every time. And it's definitely more visual and easier to follow than maybe long division for some people. So if I were to just recap the steps here very quickly. So step 1 would be draw the rectangle. Two would be to divide into rows and columns. Number 3 would be to draw the diagonals. Okay. Number 4 would be to multiply across row and column. So I would say multiply a row with column, and then 5 would be finally add each diagonal. And your answer is final number from left to right. Left to right. Okay, perfect. So I hope that you were able to follow along. If you wanted to verify what this is, we can quickly do that. So we will say 1, 2, 3 times 4, 5. So 1, 2, 3 times 4, 5. That's okay. That's perfect. That's correct. Okay. Alright, let's see what the solution says. So the solution says multiplying two or more digits from a long multiplication. So it's diagonal crisscross pattern type grid. That's perfect. So step 1 is you make the boxes, you draw diagonals, you multiply top, multiply bottom, and then you add the diagonals, and then this is your final answer. That's correct. Alright. Question number 7. This is a fairly straightforward question. I think this is even maybe middle school or primary, secondary school question. What are counting numbers? So counting numbers are described as numbers which are 1 through 9, which are used or can be called as building blocks for any other number. So you can make any of the numbers using those numbers basically. So question 7. All numbers from 0 to 9 are called counting numbers. Actually, these are from 1 to 9. Called okay, so again, fairly straightforward question. There's no need for a much more detailed answer in this case. So all positive integers, so that's correct. Alright, question 8. Again, fairly straightforward question. So squiggly sign, squiggly equal sign. So I actually intentionally used that in one of the previous questions, but what a squiggly equal sign implies is if a quantity is almost equal to or can be approximated to a certain value, we would use this squiggly equal sign. So for example, if I have a question or if I have a limit question, which is a more advanced question, which says limit of x tends to, let's say, 0.99 for a function of 1 plus x. For this question, we can say that 1 plus x would almost be equal to 2. To give you perhaps a different example, the value of pi has a lot of digits. It has a lot of digits going further from 3.14. But we can approximately say that pi, rounding to the nearest 2 decimals, is equal to 3.14. So the squiggly equal sign essentially means approximately equal to, and it's used in this context. So again, it means approximately a certain value, which is correct. So 3.1459 can be approximated as 3.14. Okay, perfect. Question number 9. What is Hinge theorem? So Hinge theorem is a theorem for comparing triangles, and we're able to identify through this theorem if we're given two triangles with similar sides, how would one triangle compare to the other. So let me just quickly draw two triangles here. Okay, and this is the other triangle. Let's say this is a bit bigger. So now it's obviously not perfectly correct representation, but I hope you would understand. So if we're given two triangles such that their sides are congruent, so what congruent means is equal in length. So if we're given a triangle A, B, and C such that this length is equal to this length and this length is equal to this length for this triangle D, E, and F, what Hinge theorem says that the third side of the triangle would be bigger for the triangle which has the bigger interior angle. So what that means is if this angle is theta and this angle is alpha, if alpha is greater than theta, we would have DF in length would be greater than BC in length. Okay, so if I were to write that down, so for two triangles with two congruent sides, the third side would be longer for the triangle which has a bigger enclosed angle. So again, what that means is, since in this case we had BA equal to DE and AC equal to EF, we were able to say just by looking at the angles that DF would be greater than BC through Hinge theorem. Alright, so let's look at this answer, especially when comparing if two triangles with two congruent sides and one side with, that's perfect. So in this case, we're given an example where alpha is 75 but beta is only 50. So right off the back we can say FE is greater than CB. Therefore segment FE is long. Okay. Next question. Question 10. What is under root or square root of 81? So for this question, we need to know prime factors and square roots and their properties. So square root of 81. First, what I would do is I would write down all the prime factors for 81. So to identify prime factors, we start by 2 and we go all the way up to 7 and 8 to try and identify if there are any numbers which this is divisible by. So we start with 2, it's not divisible. Since the sum of the two numbers is 9, we know right off the back that this is divisible by 3. So 3 times 2 is 6, and then 6 times 7 is 21. So that's 27, and then 3 again gives us 9, and then 3 gives us 3, and then 3 gives us 1. Therefore, the prime factors of 81 or 81 can be written as under root 81 is nothing but under root of 3 times 3 times 3 times 3. From here we can say this is equal to 3 squared times 3 squared, The other property of a square root which we need to know is that if we have a square root of a times b, this is the same thing as square root of a times square root of b. So using that property, what we can say is this becomes under root of 3 squared times under root of 3 squared. Under root of 3 squared is nothing but 3, which gives us 3 times 3 or 9. Therefore, under root of 81 is nothing but 9. So looking at the solution, under root of 81 is 3 squared times 3 squared under root, which is 9. So that's perfect. Okay, next up we have a trigonometry related question. What is cos of negative 90? So for this we need to know what a unit circle is and how the different quantities on the unit circle measure out. So let me draw a circle and coordinate axes here. Okay, so a unit circle is a circle which has the radius of 1 unit, and from that we can use it to identify various trigonometric angles and values. So on this unit function, if you recall, if we are going in the counterclockwise direction, so the counterclockwise direction is this direction, counterclockwise, we have the positive angle. However, if we're going in the clockwise direction, the angle is actually negative. So what negative 90 means is we're starting from here, but we're going in the clockwise direction till we get to the 90-degree mark. So this would be representation of what negative 90 is. And then to identify the values, we know that when at this point where the circle intercepts the y-axis, this point is nothing but 0, -1. So therefore, the value at this point is nothing but -1. The reason I know it's -1 is because it's called a unit circle, the radius is 1, and when I'm at this point, I'm 1 units away from the center, which is the origin. Therefore, cos of negative 90 would be -1. My apologies. When we're looking at sine, that would be -1, but cos is, so cos sine of 90 equal to -1, but cos of negative 90 is actually equal to 0. Okay, so this is correct. Alright, next up we have another square root question, which is fairly straightforward. When we try to do the prime factorization for this number, we actually notice that it doesn't have any prime factors. So based on that, what we can say is the easiest way to estimate this would be we can identify two numbers which have squares close to this number. So 36, or sorry, under root of 37, it falls between 36, which is nothing but 6 square, and 49, which is nothing but 7 square. So right off the bat, we know that 37 would fall between these two numbers and fairly close to 6 square. So we can use the calculator to identify that the square root of 37 is nothing but 6.082. Okay, so this is correct, which is also in radical form. Radical form is when a square root could not be simplified any further, and it's in the simplest form. Okay. Next up, question 13. So this is the bit advanced question. It says use the disk method to derive the formula for volume of a Frustum of a point. So for this question, let me first quickly draw the coordinate axes. So we have the coordinate axis here, and then we have a cone. A frustum is essentially something which has a decreasing radius. So if I were to draw a cone here, let me use lines actually, so that's clear. Okay, and then alright, so this would be a frustum, and we need to find the volume of this shaded region. So we need to find this volume. The way we would do that through the disk method is first we would identify a small portion on this and use that to integrate over a given range. So let me just quickly identify what I mean by that. So given we need to find this volume, this is y and this is x, the radius goes from this value r to a value of small r on the other end, and this x coordinate is equal to h. So what we can do, so we know these 2 points, so this point becomes 0 comma r, and then this point becomes h comma small r. So we know the slope of any given curve can be given by y2 minus y1 over h2 minus h1. So in this case, y2 is h comma r, so y2 is r minus r over h minus 0. So this is the slope for this line f of x. Given the slope, we can say that the equation of the line is nothing but y is equals to mx plus c. In order to find c, what we can do is we can substitute x equal to 0. At x equal to 0, y is equals to r. Therefore, c is equal to r. So when x equal to 0, y is equals to capital R, but we also know that y equal to c when x equals to 0. Therefore, c, which is the constant in the equation of the line, is nothing but it's equal to r. So we can say from that the equation of this line f of x is nothing but r minus r over h times x plus c. So now that we've gotten the equation of this curve, what we can do is we can start implementing the disk method. So what exactly is the disk method? Let me quickly use this as well. So the disk method says that if I divide a given shape into small number of disks, and if I add the area, or in our case the volume of each of these disks, I can get the overall volume of the shape. So for our example, basically, let me quickly draw it out for you. Okay, so it doesn't want to pan, so let me just get rid of it and just quickly draw it down. Okay, so if we're given this shape, and if I look at a very small portion of this shape, if I just look at this portion, okay, and we can call this our disk, since when I revolve this around the x-axis, it forms the shape of a disk. So when I'm looking at just this small strip, what I can say is the distance it covers on the x-axis is very small, and we can call that distance equal to delta x or dx. So this distance is very small, so we can say this is equal to dx. And in terms of the radius it has, so when I revolve it, it'll look something like this. So if I were to revolve it around the x-axis, we would have something like this. Okay, that's much better. And with the center here, and then this is the radius. So in our case, the radius is nothing but the function y, since we know the function, and this is the small delta x. So the volume of this disk would, we can say, is equal to volume is equals to pi r square h. In our case, r, which is the radius, is nothing but this f of x function, or y. So we can say y pi y square, and h is nothing but the small delta x in our case. So it'll be pi y square dx. Since we're calling it small volume, this actually becomes dv instead of big V, which is the overall volume. Now in order to solve or calculate the overall value, we would need to perform integration. So we would integrate both sides. Both sides would have the integral. Since it's integration based on the x-axis, we will use our limits for the x-axis. So we'll be integrating from 0 to h on the x-axis. So we'll be integrating from 0 to h, 0. Actually, that's correct. Okay, when we integrate dv, which is a small volume, overall this entire h, we actually get the overall volume. So on the left hand side is very easy, it becomes big V, but on the right hand side, this integral, so we already know what y is from this equation above. We know y is equal to this, so we can substitute that and start performing our integration calculation. Okay. So pi, which is a constant, can come out of the integral, and then this becomes r minus r over h x plus r whole square times dx. Now if we solve for the whole square, we would get volume is nothing but pi integral 0 to h, and then we use the formula for a plus b whole square, which is equal to a square, so r minus r over h times x squared plus b squared plus r squared plus 2ab, so plus 2r minus r over h times x dx. Now we can multiply dx with each of these, and since we know a common rule for identity, which is for an integral of f of x plus g of x, dx is actually nothing but integral f of x dx plus integral g of x dx. We can use that here to split this into three integrals. So what would that give us is volume is equal to nothing but pi integral of 0 to h for r minus r over h whole h, well, it's actually a square here, square x square dx plus, and then we have to be careful, pi is being multiplied to all of this, so that plus r square, or integral of 0 to h r square dx plus integral of 0 to h 2r r minus r over h x dx. Okay, so if you recall the property of integrals, we know that integral of x to the n is nothing but x to the n dx is equal to x to the n plus 1 over n plus 1. Based on that, we can calculate all of these. It's important to know that all of these values are constants, so they would also come out if we were to solve for the integral. So this integral becomes r minus r over h x cubed over 3, and then this has limits of x from 0 to h plus r squared dx becomes nothing but r square x again from limits from 0 to h, and then this becomes plus 2r r minus r over h x squared over 2, again with the same limits from 0 to h. Now when we do substitute for the limits, we should know that the first quantity gets substituted in, minus you substitute the second quantity. So for the final formula, we would get pi. Every time we substitute x equal to 0, the term actually becomes 0. So our final formula will be r minus r over h x cubed over 3 plus r square h plus these two get cancelled. You get r minus r over h. There's another r here, h squared. So after simplifying, this h gets cancelled, this becomes square, and then this h gets cancelled, this becomes 1. So the final formula for volume becomes pi r minus r h square over 3 plus r square h plus r h minus r square h. Once you simplify them, and then these two terms get cancelled. So you're basically, for the final formula, left with volume is equals to pi r h square over 3 plus rrh minus rh square over. Alright, so there was a bit of a long solution, but this is the final answer. Let's look at okay, so again, integrating from 0 to r using the disk method, 0 to h. This is r, this is small r, so perfect. We'll open the integral, the limits gets carried forward, pi comes out. So for the final answer, we get let me just maximize this. Where did the RH term get 3 from? I see. So they have just used overall multiplication. I see. Okay, so the final answer is correct in their case as well. What they have shown, essentially what they've done is they have further simplified this expression, saying volume is nothing but, if you were to take the overall sum, you would get pi again, I think r minus r, so that's r squared plus minus r squared plus. Okay, so yeah, I think their solution is missing this term, which was r minus r. I think there should have been a minus here. So again, anyways, if we were to take the common h out of it and then divided by 3, we would get rh plus 3rrh minus rh as the final answer. See, okay, so quick solution correction. This is actually h squared, so over here this gets cancelled, and so does this. Okay, so the final answer actually becomes what they have, which is correct. R square h plus RR plus R squared. Okay, so the error which was made here was this was actually to the square, so h actually becomes a square as well. Okay, all right, I hope that was somewhat clear. Awesome, appreciate you guys tuning in. Thank you so much, and hopefully you have a great day. Please check out the link in the description if you have any further questions. Take care, have a nice day.